Welcome back to Infinity Beyond. Tonight, we step out of the ancient past and into a pressing present. We've journeyed through a time when Earth froze from pole to equator. We've seen how life endured beneath the ice, how volcanic CO2 reversed the freeze, and how snowball conditions gave way to explosive evolution. But the Snowball Earth story doesn't just belong in the deep past. It's a mirror, a warning, and perhaps a guide. Because today, Earth faces a different kind of planetary transformation. Not one driven by cold, but by heat. And surprisingly, many of the same climate mechanisms that once froze Earth may now be pushing us toward dangerous warming. Let's start with what triggered the Snowball Earth glaciations. Back then, carbon dioxide levels dropped, likely due to increased weathering, continental shifts, and declining volcanic output. As CO2 fell, Earth's greenhouse blanket thinned. Less heat was trapped, ice expanded, and a runaway positive feedback loop began. Ice reflected sunlight, cooling the planet further, causing even more ice. Fast forward to today. We are now pushing the planet in the opposite direction, but with the same dangerous feedback effects. As human activity releases billions of tons of CO2 annually into the atmosphere, Earth is warming. Glaciers are melting. But here's the twist. As the polar ice disappears, the planet absorbs more solar radiation, accelerating warming, much like it accelerated cooling during the snowball phase. It's feedback in reverse. And it's just as powerful. In fact, climate scientists today model tipping points that eerily echo those from the Cryogenian period. Once Arctic sea ice shrinks past a critical threshold, it may vanish entirely during summer months, altering global weather patterns, jet streams, and ocean currents. Another risk lies in methane clathrates, frozen methane trapped beneath ocean sediments and permafrost. As temperatures rise, this methane can be released, a greenhouse gas far more potent than CO2. A sudden burst of it could trigger rapid warming, akin to the volcanic CO2 spikes that ended Snowball Earth. The past shows us how quickly things can change. During the snowball episodes, it took millions of years for CO2 to build up naturally. But when it did, warming came violently. Sea levels surged, oceans acidified, species either adapted or vanished. Earth recovered, but it took millions of years. We don't have millions of years. Today's CO2 rise is occurring hundreds of times faster than it did in the Precambrian. We are compressing geologic-scale climate change into mere centuries. And while Earth will survive, human civilization, with its coastal cities, delicate agriculture, and vast infrastructure, may not adapt so easily. But here's the paradox. Snowball. Earth also shows us that Earth is resilient. The biosphere bounced back. Life not only endured, it innovated. The ice forced evolution. New forms emerged. Complexity grew. There's hope in that. Yet that same resilience doesn't guarantee stability. The lesson isn't that we can do anything to the planet and expect it to bounce back unscathed. It's that climate swings, hot or cold, come with immense cost, and they're often driven by the same trigger: carbon. We're now living in what some call the Anthropocene, a new geological epoch where humans are the dominant force shaping the planet's systems. Unlike ancient volcanoes, we control the levers: fossil fuels, land use, deforestation. And we're pulling them fast. So how do we respond? Snowball. Earth teaches us two key things. First, feedback loops are real and powerful. Whether it's ice reflecting sunlight or methane accelerating warming, Earth's systems react quickly once thresholds are crossed. Second, recovery is possible, but it takes time and leaves scars. It's far easier to prevent tipping points than to reverse them. Already we're seeing early warnings: heat waves, droughts, supercharged storms, and collapsing ecosystems. These are not isolated events. They are connected ripples in a system under stress. But there's still time. Renewable energy, carbon capture, ecosystem restoration. These are not just solutions, but necessities. We cannot afford to wait for the climate to fix itself. Earth fixed itself before, but without us. And if we push too far, the planet may survive, but our version of civilization might not. This is why scientists study the deep past, not just for curiosity, but for caution. The rocks remember. They hold stories of great extinctions, dramatic rebirths, and climates both unimaginable and deeply familiar. And when you connect those dots, from ancient ice to rising seas, from frozen bacteria to melting permafrost, you realize we are not separate from that story. We are living it again. At Infinity Beyond, our mission is to illuminate the cosmos, but also to honor this planet, the only one we truly know. The Snowball Earth story is not just about how life survived the cold. It's about how we, today, must survive the heat. In our next episode, we'll explore how scientists recreated ancient snowball conditions in the lab, modeled its planetary mechanics, and continue to test the limits of Earth's resilience. Until then, stay informed, stay inspired, and as always, keep exploring with Infinity Beyond.